Hey, welcome back. So in the last video, we looked at tools for dealing with working with data encoded in JSON format and in HTML, if you can think of that as a format. Um, and that was building on concepts that we looked at in the first video, like how to use command line tools, and this principle that you can have these tools that do specific things and then glue them together with these concepts that we call piping. We're basically gluing the output of one program into the input of another program. And the whole idea there is that we can have specialized tools, but we can compose them into more generalized and complex solutions, right? And so this video today, we're going to be focusing more on working on data inside of CSVs. And here we'll spend a little bit more time because we'll be working with something called CSV Kit. And CSV Kit is a suite of tools. There's more than one when you download and install CSV Kit. What's nice is that it's got different tools to solve different problems with CSV, but they're all designed to work together. It also supports dealing with very large and compressed zip files, or compressed CSV files, excuse me. So there's gzip, which is one algorithm and it just automatically knows how to read that, or another algorithm called bz2. And this is useful and relevant if you're maybe working with a vendor or working with a client, or just someone thought that the easiest way to send you a database dump was in a CSV file. These can get quite large, and it can be a lot of work on a program to try to open it all at once in memory. So we have these things called compression. So it's nice that these tools can basically read this data without uncompressing the entire file. It just uncompresses as much as it needs as it works through the file, and that's just automatic and built in. So to get CSV or CSV Kit on your computer, it's built with Python, which makes it cross-platform. So if you have a system that can install Python, so that would include Windows and Linux and Mac, you should be able to install it with Python's tool called pip. And there's instructions on the CSV Kit homepage, which is linked to from over here. And I believe I believe that this goes straight to the installation page, so you can find all that information there. And this link to this GitHub, if you're not already aware, will be in the link in the description of this video. So yeah, really just the cool part though is we probably all have to work with CSVs, and they're very common, and it's a really cross-compatible format. So it's nice to have a bunch of tools where we can do really cool things with CSV Kit without having to write any programs. So let's dive in. So the first two that we'll look at, which is pretty cool, is CSV SQL and SQL to CSV. They work the same way. Basically, CSV SQL is from going from a CSV file into SQL. And so that is to say, if again a vendor or a partner sent you like a product spreadsheet or something like that, and a separate one that's got like product IDs, and you want to load that into your database for further analysis, this will generate the insert statements to create the tables and load that data from the CSV file into your database. The other thing we can do going the other way then is probably what's more common is if you've got a table that you want to download from a database, or maybe you've got a query from someone else at your work, or you wrote a query and want to be able to just generate CSVs from it on a regular basis. You can, in this example, save that query. Here it's saved as a string, but you can also probably store it in a file and run it that way. And you can run this program and basically output to a CSV. This character here we haven't looked at before. So I showed you before in the first video how piping worked, right? So we have that vertical pipe, and that says normally my program would just print to the terminal, but I want it to write to this other program instead via the pipe. This arrow bracket here is saying I want to redirect the output and send it into this file, right? So pipe is for sending to other programs. These redirect operators are for sending to files. And so to package it all that together, CSV or SQL to CSV is taking a database connection here, and it's taking a query and is writing it to a CSV. And you only need to save that command once, and it'll just work every time. The other thing that's nice though is, so this syntax here is basically like the database connection string. right? And normally it has authentication and things like that in it. But because it's declaring that this is the protocol, is PostgreSQL, this command is automatically going to know, oh, I know that I'm dealing with a Postgres database, or maybe it knows that it's dealing with a MySQL database or a Microsoft SQL database. What's cool is that it knows all those database specific syntax. So it's when it's going to write insert statements, it's automatically going to figure out what the types for each column should be based on what data it finds in the CSV. So it's pretty smart about writing to and from databases. CSV JSON is for turning CSVs into JSON data. And that's a useful conversion tool, but you might be thinking, like, when would I ever need to do that? We'll look at some specific examples, but usually this is interesting if you've got programs that deal only with JSON as input or are expecting JSON as input, but you've got all of your data encoded in CSV. So this helps you convert. The way that it works is it just reads what the column names are in the CSV, and then those column names become the properties for that JSON object. But some other options that you can use to change its behavior, rather than emitting all of the contents in the CSV in one collection or as one list, we can have it instead emit each row in the CSV one at a time. And that's helpful for, again, programs that if you just want to be able to deal with each entry one at a time, or it only can deal with each entry one at a time, this is a useful option. The escape character is helpful if you've got a CSV. I think we've all probably encountered weird formats like how to encode a comma in a column, or if you've got like a text response and the user's using quotes and columns and things like that. This will tell the program what characters you're using to escape those characters. And then finally, we've got max fields. So for really strange columns that exceed a certain number of characters, you can control how much it will allow. So let's look at an example. Maybe you've got a program that takes JSON, but your data is in CSV. So instead, we can run them through CSV JSON and send them or compose them with another program that knows how to read that format. So for here, and as an example, we're emitting from CSV JSON each row one at a time in a stream. And then parallel is kind of like a program that we saw earlier called xargs, but basically we're going to take each input and we're going to run it into another program that many number of rows each time. So here what we're saying is we're going to pipe that data into curl, which we've looked at before. And here what we're doing is we're forming a web request to a fake API. We're going to push that data, so that's called the post method. And we're going to tell that endpoint or that server, I'm going to send you some JSON. And then here, this little @ symbol with a dash, that is my input. So the data that I'm sending to the API is the CSV row that got transformed into JSON. So again, this is handy, is if you've got a bunch of data CSV and you want to send them to an API, you can do that with something like this. So let's look at convert to JSON over here in the examples. So again, as with all the other scripts, you'll be able to see this. This same file lives over here in examples CSV Kit. And so when you're trying these things out yourself, you'll be able to download this and play with it, and it'll come with all the instructions for what it's doing. So here we're basically just, at bare minimum, we're just turning rows into JSON. So like, let's look at some examples. I've got, let's look in here inside of the examples and we'll go into that. So I've got up here in my inputs directory, Florida Insure Examples CSV. So let's zoom in on this. Right? So let's print that out to the screen so we can see what we're looking at. It's just a bunch of stuff. It looks like we've got lat longs in here, numbers, zip codes, and so on. So let's take that and just take the first 10 lines, and then let's pipe that into CSV JSON. And so what I've got now is basically I just turned those first 10 lines into a big JSON blob. Now if I just want each row on its own line, that's where I can put stream. And so that's a little bit hard to see. So let's just take the last one, and then let's run it through that JQ program that we had before, and it will format it for us. So it's the same data, But without having to like kind of do anything custom here, we built up a little chain to just spit data out and transform it into CSV, right? So let's come back over here to what we want to do with this program. So we've got another API here, and it's a free service. It's just a dummy API endpoint. So like you can send data to it and it will just say, I got it. Or you can, like, let's say you need to fake a user's endpoint. You know, you can just pretend that there's a user with an ID of 1 and it will respond to things. So you can look at the recres.in later. But again, at this point, it's just a hosted API that I want to be able to send things to. So here what I'm going to do is I'm going to take the first 5 lines of my insurance samples. I'm going to run them through CSV JSON. Now in the documentation for CSV JSON, it tells me that it knows how to deal with GeoJSON, which is basically a format for dealing with location data that can exist inside of a JSON object. So what I'm going to tell it is that I've got a column in here, which you can see over here on this side, point latitude and point longitude. So these are lines inside of the CSV file. In fact, let's look at the first line of the CSV file. So these are the columns there, right? And I've got point latitude and point longitude. So I'm telling it there are some columns named point latitude, and that corresponds to the latitude and longitude. So what I'm going to do is I'm going to build up an object. So the first thing I'm going to do is I'm going to extract out the type and geometry fields. Again, that's being emitted by this. I'm going to extract those out, and then I'm going to build up another object and merge it. So I just want to dive into the properties field and pull out policy ID. I'm going to pull out the line, and then I'm going to rename construction to the field material. And just to see what we're looking at real quick, let's go back to this. Let's take the first 5 lines. Oops. Okay. And then let's pipe that into CSV JSON. And we're going to stream it. But then let's look at what happens when I do that lat long stuff. So what happens now is it's going to create, and then let's format it with JQ so we can read this. So it created, this is a JSON format, right? And I got my geometry, it's a point since I don't have like a box or anything like that, and these are the coordinates. But this is all the rest of the data that came out of the spreadsheet, right? So the geography information got moved here, all the rest of the columns got moved here. So what we're doing then is extracting out these things that we care about, and we're taking the coordinates as well. So that's what this little program does. And as you can see, we got here on the right, the type and the geometry fields. And then we're also going to, and then we reformat the other things that we care about. And so finally, what we do next is we're going to run those through a program called Parallel. And we're going to spit out what we get from each row here. And JQ is going to let us format each row the way that we want it. And if you remember, we've got these little flags. So -C, you should remember, is compact, and that's what makes it all be on one line. R is a new character, and it's basically saying raw, because we're passing this raw data. We don't want it formatted for people. We want it formatted for another program. So I'm going to send it to the API URL. Post, again, is an HTTP method that says I'm pushing data to this endpoint. I'm going to tell the server that we're sending you JSON, and then we're sending the contents of the file, right? And I have I left a note in here about why we use parallel versus xargs. And this is only really something that you're going to care about if you get into like more difficult problems. You're certainly welcome to reach out to me or kind of look up for yourself like parallel versus xargs with quoted data. But anyway, let's run that here. We'll run convert to JSON, and hopefully this endpoint is still up. Yeah, so what it just did is it spit back out to me its responses, right? So I ran each 5 in parallel, and it almost looks like nothing new happened, except we see that it added these new fields called ID and created at, which is the timestamp that we just sent it at. So this is the API responding to me and saying, I got your data that you uploaded to me, and it just worked. Right. So again, this could be handy. Like you only have to like maybe write this once. You're not writing any raw code. If you maybe you consider JQ code, but Either way, you're not having to learn a program. You're not having to download an IE, like a programming editor or something like that, or compile anything. It's just existing programs, and you're gluing them all together, and you can save this in a file. And maybe you just need to every month or something like that, you've got data that you need to upload to an API. So this is something that can help you with that. Cool. Moving on to another example, we've got into CSV, and this is kind of going the other way. Instead of going from CSV to JSON, we can go from other formats back into CSV. And it's a little bit more limited in what we can do. So for JSON, for example, we can represent like nested data or a list, or like a list that has objects inside of it. CSVs aren't as flexible about representing that kind of thing, so you do want to be a little bit thoughtful about what you send to the CSV. It's got a few formats that it knows how to read. I actually had to just do this recently where a vendor sent me some data that was in Microsoft Excel format, and I could turn it to CSV, so it was like a good conversion tool. It knows how to read JSON, and so I can get just like a single page or a single document and turn it into CSV, but it also knows how to deal with rows of JSON. So in the second video, we worked on a program called Station Weather. So let's come back up over here to JQ folder. So if you don't recall, we had the Station Weather program, and it just spit out a bunch of stuff, right? These are the weather observations in JSON format. Well, if I want to make that into a CSV, I'll do into CSV, and I'll have to tell it that each row is its own JSON. So that's new line delimited JSON. And that spits out a CSV file. And I showed you earlier that instead of, I can't say pipe to a CSV because it's expecting a program, but I can write like that. So that's the redirect operator, and I can turn that into CSV. Except there's a parse error, but that's fine. So now here I've got the CSV, and again, this is helpful if you've got some kind of program, like maybe this is like an HTTP request to, like if your logs are stored in a web service or something like that, and it responds all of your logs to JSON format, and you would rather work with them in CSV, you can use JQ in between to process them if you like, or you can run them through, and then you can eventually run them through into CSV and save them as a CSV. And so that's really helpful. Again, your root data might not be in the format that you want later, but since everybody can work with CSV, you can use, again, something like into CSV and convert it different kinds of formats into CSV. CSV Cut is really handy. You can use it to look at what columns are in a file, and you can use it to just say, I only want these columns. So let's say that I have something called data CSV, but I only want these 3 columns. That's what I would use. And again, if I could use, let me look at report. If I use CSV Cut -n on report CSV, it tells me, hey, here are the columns and the numbers in it. So that's really helpful if you're getting a new file that you haven't dealt with before, and you just want to say, I only want the station codes. So that would be -c, I think, station of report. And then that just gives me a new CSV with only that in it. Same thing if I put summary in there, I get those columns, right? So that's what that does. And then CSV Join, a little bit more complicated, but the idea here is maybe you've got data spread across 2 CSVs. I recently had a problem like this where in one CSV, it was just all of the codes for categories, and the next CSV was a bunch of businesses and their categorization code. But I wanted to be able to join them together. So in this case, I can give it those 2 CSVs. And here in this example, let's say we've got a spreadsheet that contains details about an item or a product, and then another, like a price sheet. And you want to do some analysis and join them together. So CSV Join will say, these are each of these files has a column called item ID, and that's how you match up the rows. And then, we can pipe those into a JSON format and compress them and then save them to some file called output. CSV Stack is kind of simple idea, but let's say that you've got a lot of data that's spread across 3 files. So in this case, maybe log exports for 5 days. They might be in different files. You can combine them all into one CSV with CSV Stack. So let's look at an example of just something kind of dorky to pull data out of this Dragon Ball Z page. I used to watch this when I was a kid, and there was always just these they would just assign these random numbers, and like here they would get kind of normal, they're just in the hundreds, but then all of a sudden it would leap to 9,000, and that was great. 21,000, just these absurd numbers, right? So we want to work with this data, but it's not in a format that's easy to extract. There's no JSON LD, there's no download, there's no API for this, but we can still get this data out. So that's what we're going to look at in these examples. So the steps that we're going to do is we're going to first use curl. We've used that a lot in all of our videos to download the raw HTML. And then we're going to use pup to extract the data that we want out, right? Because this is all pretty well structured. I mean, we know that there are table tags to pull things out, and we can kind of figure out what these tables are called and look at its structure and get the data that we want. Then we can use JQ to turn to process. Like if we extract all the rows and then turn them into JSON, we can use JQ to process that further, and we'll just extract the data from so when I say DOM, that's the document object model, but it's basically like the nested structure in HTML that contains all this data. And then we can calculate some statistics, and then we can finally save everything to a CSV. So let's go to our Dragon Ball Z folder. So if we look inside of this folder, and I'll come back up over here, we have a bunch of files that have spread across a few files, and this also introduces something called a make file, which you don't need to learn. It's basically just a task runner, but I'll touch on this and why you would want a task runner later. But let's look at the steps in order. So the first step is get the raw input. So this is the URL that we'll pull it from. I will clean up real quick, so we'll just do this one at a time. So we've got pretty empty, just the scripts. We're going to curl that URL and save the data to this levels.html file, and then we'll print out. That's what echo does. Will let us know that it worked. So let's run this, and we downloaded raw HTML levels, and there's levels.html. And if we print out that file, we can see that's the Dragon Ball Z source code for that page. Okay, so the next thing that we'll do is it expects that levels.html file exists. So this angled bracket, so normally we redirect going into a file. This is redirecting and saying we want the contents of this file to go into this program. I could have easily just done the same thing by saying levels.html and piping it. This is just another style of doing that. So we're piping data from levels.html redirecting into pup. And we're going to look for any table with a style, or with a class rather, called wiki table. And then we're going to look for all of the rows inside of those tables, and we want every other row. And so that's what this nth of type n+2 means. And this is just, again, these are CSS selectors. And then we want to turn each row from the table into JSON. So this gives us all of the tables, all the table rows that it finds in JSON format. So let's run that. And if we look at extracted table rows.json, we see this is the format that pup gives back, right? So each table row that it finds has children in it, and those children have children. And eventually you drill all the way down and you get to, these different, rows. And like the things that we want would be, where's an example? So here is the column that has the power, and then this is for that character, right? So we want to go from that JSON to the stats, right? And there's a lot more text in here because this is using more advanced JQ. Most of your problems won't be this nuts. But this is just going to kind of show off that JQ can do a lot of things. And so you'll read all of this if you feel like you have time and want to learn JQ more deeply. But I'll kind of walk through what it does. So we're going to first, so when I said map, so the data is all in one big list. So we're going to go through each item in the list, and we want to look to see if something is true. We want to select only the ones for which this thing is true. It needs to at least have, a second child or any other children that exist at all. And then that filters those rows. So this is how we filter rows in JQ, map select. Then we want to, for each row that passes that filter, we want to build a new object for each one where the name is diving into the children of that row. So we want to take the second child and then the first child of that and then take the text. So this is basically that column and get out the text. And then we're going to take the next column and then take the text. Now, in the spreadsheet, or sorry, in the table over here, it's kind of formatted. It's got like, we've got commas for things that are at least over 1,000. It has some dashes and things like that too. So what we say instead in this program is we want to dump everything. So that's what gsub is, global substitute, everything that isn't a number, and replace it with an empty string. And if we're left with an empty string after that, we just want to default to 0, because then we're going to pipe that into a function called toNumber. And I get that this is a bit complex, but like you can build your way up into learning this in JQ. And this operator here is basically, it's the default operator. So if it means if the thing on the left is empty or non-existent, then replace it with the thing on the right, or default to that. I did have to leave a note in here that there seems to be a bug in JQ 1.6 with that operator. JQ 1.5 does not have it. That only is going to matter to you if you're trying to use this operator. For the most part, I very rarely use it. I had to make up a Dragon Ball Z example to run into this problem. And then we print out an array of all that and we save it to new nd.json. So let's run step 3. So we'll look at the extracted stats. And so we see we've got an object with name and power for each one. So that's convenient. And then step 4 here is produce the results. So we're just going to take that format that we just wrote, and we're going to run it through into CSV, telling it that the format is 1 line of JSON per row, and then we get now results.csv. Right? And so that makes it really easy for us to go from data that was trapped inside of HTML, run it through a big processing pipeline, and save it. And we didn't really have to write any code. We did have to learn JQ, but you only really have to learn one tool and just make it flexible to solve all these problems, right? And this is just basically a nice way to kind of tie everything together. So one thing that I've been showing, all of my examples I've saved to these files, and I've ended all of them with .sh. So you'll get to a point where you want to be able to like run these little commands just to solve things on the fly. But maybe you want to save those commands because you want to do them later, right? And so you can save a string of commands to a file and then give them names so you can remember them for later. So the structure of one of these scripts, it has to start with what we call a shebang or hashbang. Hashbang is easy for me to remember, and bang refers to this exclamation point. And on your computer, you tell it the name of the interpreter. We've been working with Bash all this time. And so that lets the computer know when you run this program that this is the interpreter that we're going to use. And so in all these examples, so this, you can take in arguments. So for example, if you want to give extract address a different URL every time you run it, when you run with a URL as an argument, it will be saved as $1. That's the argument. So we can basically take a URL, pull out any LD-JSON that we find from that URL. We can replace any quotes. That's what sed does. And then we can extract out things like name, URL, telephone, and address. We can get rid of a field called type because we don't need it. And so that's just some of the stuff you can do, and like just being able to save that. That's a pretty common utility you might want to do. The one thing, especially for Mac and Linux users, that you'll want to know, if I just write some random file.shell, we'll do our shebang, bin, bash. And if you want to know where certain programs are, there's a which command. So we'll say which bash, and that's bin bash. And we'll say echo hi. So if I run, that's what this .bang means, / rather. If I run random file, it's going to get mad at me. It says permission denied. So this is getting a little bit into Linux land, but it's something that you'll need to know if you want to do this. You'll have to give it permission to be executed, so that you do chmod +x on random file. And now I can run it, right? So that's a little bit of like, that's important to any Linux and Mac users, is that you have to tell the computer that this is a file that you can run. And so that's what this // will always mean, is run this program at this location. I don't believe I have a slide in here for that, but just keeping these files in like random directories, that could be useful if you're just always keeping your scripts by the data that it lives next to. But sometimes you might want to just be able to access a program from anywhere. And so in that case, I've got a folder called my bin folder for binaries, right? And this just lives in my home folder. And all of these green ones are things that I've, little scripts that I've written. Like here's an example for new Jira. This is a script that I wrote, and it's using the bash program. And it's basically trying to say like, well, so this is the company I work for now, so I didn't want to show that. But this basically opens up the Jira URL so I don't have to remember it myself. I can do some other things, like I wrote a script to help me take screenshots on my computer. I wrote a script for printing out images on the command line. So there's a lot of different scripts, and then I put them all in this bin folder, and so they're just available everywhere on my computer. So if I said like which new Jira, it tells me that new Jira lives in my bin folder in the home directory. So for my computer to know that, I have to add it to my path. I do not remember how to do this on on Windows, but when my computer starts up, I get all of that, and I can just say, let's see, where's my bin folder? So basically when I start up, I'm going to add my local bin folder to my local path. And so my computer knows to look up, when I give it the name of new Jira, it knows to look up. Knows to look up for files named that, or for programs named new Jira in my bin folder. That's a bit more of an advanced concept. I don't have like a lot of tutorials or slides for it, but it will be useful for you to know if you want to save these programs. So then the other thing is task runners. So I mentioned already things like makefile. The whole point of wanting to do all this is that like you build up bigger programs that have dependencies that like, step B needs to run before step C, and if step B fails, then we need to fail the whole thing. So there is, like, when you do get to really large work sets, there's a program called Drake, and it's made by a company called Factual. And it's basically just a big data workflow tool, and it can pay attention and know, like, it can run all these steps in parallel, or I need to wait for that to finish. And it does some this is kind of more advanced, and I've used this for building big pipelines in ETLs, and like that was a useful way to kind of pull data from a bunch of different databases and format it for analysis. So for an example like this, maybe if we saved a copy of our database in JSON format, and I wanted to depend on that before running managed users, and I'd basically just say take input, which is my database, extract from it with JQ the users that I want, and then just remove all the duplicates, and then save it to the target, which is managed users, JSON-L. Right. Other examples here using CSV Join, this is what we learned before. And then I joined two different databases, so like our products and our product details. This is saying like the DB product step will be built off of combining these two with CSV Join, and then getting rid of duplicate columns, and then inserting them into a Postgres database, into the products table, right? And here's where I specify what I want the table to be called. And other examples, if I just take, maybe there's some sites that I need to process, but the sites come from a different report. So I will take, I can take out of the database and find all the sites that need to get processed based on some kind of status, and then write them to this sites to process JSON-L. And then we can, use other programs later that we've already learned, like JQ or into CSV, and maybe produce a CSV report to send to a client or something like that, just based on a database query. So Drake is a bit intense. There's certainly more light ways to do this, like makefile or something like that, or just writing your own scripts and doing it all manually. It really depends on your needs and how big your problems are. But there are examples of task runners that compose a lot of these things for you. Now, I do want everyone to feel like this is something that you can learn. I do want everyone to feel like this is something that's useful to help solve your problems. But it's not a solve all for everything, right? So I tried to gloss over and make my shell programs a little bit simple. I think most programmers will tell you that they hate writing shell scripts. They can get pretty nasty. When you get to a number of conditionals, or if you write like really abstract programs or something like that, usually it's better to turn to something like a programming language. So shell scripting can get messy quickly. It can be hard to read just because it takes so much investment to learn. And it's not just as obvious to everyone to read, so it's not always beginner friendly, and that's especially true even among developers on a team. The other problem here is that if a problem that you work on needs to be short, it needs to be like a quick bang it out script. If you've got some kind of problem that maybe takes a couple of hours or like overnight to run, and you're running it on a shell script on your computer, you can't close your laptop. You can't close your computer and walk away. You have to keep your computer open. Otherwise, the program suspends, right? So if your problem is big enough or long enough, it might make more sense to either write that script but put it on a server so it can run overnight or something like that, or turn that problem into something to hand over to like a bigger team to maintain. But a script can be an easy way to say, like, I can write my proof of concept, get the initial data done, and then send that over to another team and say, like, make me a program that does this in a more robust and scalable way. And finally, if your problem is sufficiently complex, we have these nice custom fit tools to solve straightforward problems, but there are a lot of problems that are not straightforward. And in that case, you might want to turn to something that is a custom program. But for just moving data around and transforming it, I've absolutely been able to get a ton done just with these CLI tools. So what I hope everyone is able to kind of learn out of these 3 videos is, you don't have to do it the hard way every time. Some might argue with me that everything I showed you is the hard way, but in my personal experience, this has been a much more effective way of getting things done than writing programs. I do want you to feel like the hard way is just something that you can instinctually avoid, and this is something that I definitely want the programmers watching to take away. Like, you don't have to write a program every time. Find simpler ways to solve the problem, and most of the times the simple way to solve a problem is to use an existing tool. This idea of discovering tools that are custom fit and tailored for your problem space. So maybe you don't work with CSVs or JSON or something like that, but there's a custom file format that you do deal with on a regular basis. Well, there's probably already a tool out there that does this, and I think spending some time, searching for tools that solve those problems, usually it pays a lot of dividends because you just find something new that's the perfect thing that solves your problem. But even if you don't go off looking for new tools, these videos are more of an awareness raising kind of thing, just to let you know that this is possible, that these are 3 tools that solve a lot of common problems, at least in the industries that I'm familiar with. I just want you to be aware. There's a learning curve for sure. I'm not going to suggest that this is just super easy, but I think it's easier than programming. There's less to set up and get started with, and hopefully the people that like Dragon Ball Z had a good time with it. And if you've never heard of Dragon Ball Z before, I'm sorry. It's just a nerdy thing from my childhood that I liked. So normally this presentation is something that I would have done in person, and you're still welcome to ask me questions though. I do want everyone to feel empowered. I do want folks to feel like they can get technical tasks completed without programming, whether you're a programmer or not. But you'll probably still have questions. You can find me on GitHub or in the comments of this video. Twitter is another really good place to get a hold of me, and I think all of that information will be available from either the video or my GitHub profile. It's the same handle everywhere. It's just the Dav, and for the sake of making this easier, I'll just put that here. So this is my Twitter handle, and you're always welcome to ask me questions anywhere you can find me. So. Thanks for watching all of these. Hopefully they were helpful. I am certainly looking for more opportunities to kind of give away what I've learned. So if you've got questions or some subject that you think would be interesting to cover, let me know and I'll make some time. All right, thank you.